Right, children. Now start with write down preparation of alcohols. In this chapter, we'll take up preparation of alcohols and phenols separately. So today we are starting with preparation of alcohols. We'll roughly study 10 methods. Naturally, we'll not be able to finish all the 10 methods in today's class. Number one, first method. From alkenes by their hydration. Hydration means addition of water. Alkenes undergo addition reaction with dilute sulfuric acid according to Markovnikov's rule, to form an alkyl hydrogen sulfate, which on hydrolysis gives an alcohol. For example, write the equation. Alkene, we have taken the example of propene with dilute sulfuric acid. Think of two parts of sulfuric acid. It is H plus and HSO4 minus. These two parts will be added to double bond according to Markovnikov's rule. We can apply more gets more. H goes to this carbon atom and HSO4 minus will form a bond with the middle carbon. Bond will be formed through oxygen atom. This is alkyl chain and this is hydrogen sulfate group. So the product is alkyl hydrogen sulfate. Then you have written which on hydrolysis gives an alcohol. Hydrolysis means reaction with water catalyzed by an acid gives alcohol. After hydrolysis, sulfuric acid will be regenerated, but it will be very, very dilute, therefore cannot be reused. We cannot reuse it. This is very dilute. Now, if we compare starting material, that is alkene, and the final product, let us see what is the change. This and this. There is no change on first carbon atom. At this carbon atom, OH has been added. On this carbon atom, hydrogen has been added. It is addition of OH and H. OH and H are nothing but two parts of water. So we can say water has been added. That is why we call the reaction as hydration. That is addition of water, hydration of alkene. Moreover, if you think of two parts of water, these two parts of water have been added according to Markovnikov's rule. More gets more. H goes to this, OH goes to this, we get this product. So write down both these steps can be combined together and the reaction can be represented as follows. So write the equation again. After the arrow, we'll write number one, dilute sulfuric acid. Number two, hydrolysis. As I told you, addition of water will take place according to Markovnikov's rule. So product will be H and OH according to Markovnikov's rule have been added. For the writer, overall, this method involves addition of water to an alkene according to Markovnikov's rule, and therefore called hydration of alkene. Now you have mechanism of this reaction in the syllabus. Next paragraph, write down mechanism of the reaction. Mechanism of the reaction. This reaction takes place in three steps. That is step one. Protonation of alkene to form a carbonium ion. Right on. In this step, hydronium ion makes electrophilic attack on C double bond C and provides H plus ion, which forms a bond with that carbon atom of C double bond C, which is linked to a shorter alkyl chain, or which is less alkylated, or which is attached to more number of hydrogen atoms. For example, now in the first step, two reactions will be involved. We are using dilute sulfuric acid. It means there is water, there is sulfuric acid. Sulfuric acid will give H plus ion to water, and this will change into hydronium ion. This hydronium ion will make electrophilic attack on carbon-carbon double bond. Hydronium ion will give H plus ion to double bond, that is alkene. After it has given away H plus ion, it will change into water. Now, where will this H plus ion given by hydronium ion go? You have written this H plus ion provided by hydronium ion will go to that carbon atom of C double bond C, which is linked to a shorter alkyl chain, means this one, or which is linked to more number of hydrogen atoms, again this one, or which is linked to which is less alkylated, again this one. So H will form a bond with this. Naturally, plus charge will go to the other carbon atom. So this will change into CH3. So H plus ion forms a bond with one carbon and positive charge goes to the other one. What is this? If you remember, you studied in 11th standard, this is nothing but electromeric effect. This is electromeric effect. Next item, step 2. Step 2. Nucleophilic attack of water on carbonium ion to form an oxonium ion. Now look here, what will happen in the second step? These two products, that is carbonium ion and water, they will react together. Water will make a nucleophilic attack on carbonium ion. So write the equation. In this product, oxygen will carry positive charge. Therefore, this product is called oxonium ion. Now, before we proceed, let me tell you one very important thing. Like in this mechanism, whenever you have to write a mechanism, particularly in CBSE exam, showing movement of electrons with the help of arrows like this one. This type of arrows have to be compulsorily drawn. Even if rest everything is correct, you will get 0 if you do not show movement of electrons with the help of arrows. That's what is discussed in head examiner's meeting before evaluation is done. Right? I've attended many meetings. They clearly specify, examiner question paper setter clearly specifies if the child has written everything correctly in the mechanism but has not drawn proper arrows, give 0, don't give even 20-25% marks. So be very careful. Next item, step 3. Step 3, deprotonation. Deprotonation means removal of H plus ion. Deprotonation of oxonium ion to give an alcohol. Write the equation. You can check in first step, HSO4 minus, that is hydrogen sulfate ion was formed. Now, this H plus will combine with HSO4 minus to regenerate sulfuric acid. These two electrons of the bond will go back to oxygen. Positive negative charge will be neutralized and there will be two lone pairs of electrons at oxygen atom in the final product. So it will be CH3, CH, CH3. Oxygen will carry two lone pairs of electrons. You can see sulfuric acid is regenerated. In alcohol, oxygen atom carries two lone pairs of electrons. second method of preparation. By oxymercuration, all right, oxymercuration, demercuration, by oxymercuration, demercuration of alkenes. That a reaction of alkenes with mercuric acetate, means mercury salt of acetic acid, mercuric acetate, followed by reduction with sodium borohydride. Sodium borohydride gives an alcohol and the overall reaction is hydration according to M rule, that is Markovnikov's rule. For example, I've taken 2-pentene as an example. Number one, mercuric acetate in the form of aqueous solution. So this is CH3COO twice Hg. Oblique water means in the presence of water, followed by NaBH4 is sodium borohydride. You have written overall addition of water will take place according to Markovnikov's rule. Now, if you think of two parts of water, H plus and OH minus ion, in this case, you cannot apply more gets more because both the carbon atoms are linked to same number of hydrogen atoms. Now, in this case, negative part, that is OH minus ion, will go to this carbon atom because this is linked to a longer alkyl chain. So product obtained will be 3-pentanol. This is oxymercuration, demercuration reaction. Third method, from alkanes. That alkanes containing, in fact, this is the reaction we studied in 11th standard also. Alkanes containing tertiary hydrogen atom. Tertiary hydrogen atom give a tertiary alcohol on oxidation with acidic or alkaline KMnO4 or K2Cr2O7, potassium dichromate. For example, I've taken the example of an alkane in which tertiary carbon atom carries hydrogen So this is tertiary hydrogen. In the reaction, this hydrogen will be replaced by OH, and for that we can use acidified or we can use alkaline KMnO4 or potassium dichromate. So we can use KMnO4 sulfuric acid, means acidified KMnO4, or we can use alkaline KMnO4. In place of KMnO4, we can also use potassium dichromate, that is K2Cr2O7. No balancing, no byproducts are required. Just replace tertiary hydrogen by OH group. Remember, if there's no tertiary hydrogen, oxidation of alkane will not take place. Next, fourth method. From alkyl halides. From alkyl halides. I hope you remember alkyl halides undergo NSR to give alcohol, but a little more detail is required here. Pattern. Primary and secondary alkyl halides undergo NSR with aqueous NaOH or KOH to give an alcohol. Equation. It has to be primary or secondary, but not tertiary. Although when I taught about alkyl, aryl, and aryl halides, there I did not tell you why not tertiary alkyl halide. Naturally, all details cannot be given at the same place. Only primary and secondary will give corresponding alcohol. So primary alkyl halide will give primary alcohol, secondary alkyl halide will give secondary alcohol, plus of course the byproduct will be sodium halide. Now what will happen if we use tertiary alkyl halide? Right on. However, tertiary alkyl halides give an alkene according to Say's rule. For example, this is tertiary alkyl halide with aqueous NaOH. Product obtained is not a tertiary alcohol, so you cannot blindly write that the reaction is NSR and will lead to the formation of alcohol. In case it is tertiary alkyl halide, then elimination reaction will take place. We'll get an alkene according to Say's rule. We'll get 2-methyl butene. That is the product obtained. Plus NaX and water. And this is not a good method. This is not a good method to prepare alcohols because alkyl halides are themselves prepared from alcohols. Next method. I think this should be method number 5. From acid derivatives. from acid derivatives. I hope you know there are 4 acid derivatives: acyl halides, esters, acid anhydrides, and amides. These are 4 acid derivatives. Out of these 4 acid derivatives, except amides, remaining 3 we can use for the preparation of alcohols. Write down. Except amides, other acid anhydrides, other acid derivatives, give alcohol on reduction. Random equations. RCOCl is acyl halide with lithium aluminum hydride gives primary alcohol and HCl. Second derivative we are taking acid anhydride. RCO twice O, again lithium aluminum hydride, will give 2 molecules of primary alcohol. Third acid derivative we are taking is an ester. This will give 2 molecules of alcohol. One will be this part and second will be this part. So one is RCH2OH and the other will be R-OH. First alcohol, RCH2OH, will be primary. Second alcohol may be primary or secondary, rarely tertiary, but generally primary or secondary. That will depend on structure of the ester. Further write down, esters also give alcohol on acidic hydrolysis. Means reaction with water in the presence of an acid. RCOOR dash plus water. We can use any acid to catalyze the reaction, will give same 2 alcohols which I gave in the last equation, RCH2OH and R-OH. Next method. Number 6. By the reduction of carboxylic acids. With lithium aluminum hydride or diborane. Diborane is being used as a reducing agent, which will not come across anywhere else in chemistry in your syllabus. So I'll repeat, with lithium aluminum hydride or diborane, carboxylic acids are reduced to a primary alcohol. Equation. Diborane is B2H6. In place of B2H6, you can even write BH3. That is correct. Gives primary alcohol. Something important about this reaction. See, if we use diborane as the reducing agent, diborane is a cheap compound. It's not an expensive one. But if we use diborane, then yield of the product obtained is low. Whereas if we use lithium aluminum hydride, yield of the product is high, but lithium aluminum hydride is an expensive reducing agent. Now, if we want to reduce the cost and we want to get high yield of the product, then carboxylic acids can be converted into primary alcohol in two steps, not direct step. Rather, we use two steps to get high yield of the product and at low cost. What are these two steps? In the first step, carboxylic acid will be converted into an ester. After that, ester will be reduced by using a cheap reducing agent, and we get high quantity of primary alcohols. Right on, next paragraph. Although reduction with LiAlH4 gives high yield of the product, but it is an expensive reducing agent. Expensive reducing agent. Therefore, carboxylic acids are converted into primary alcohol in two steps. In the first step, carboxylic acid is converted into an ester which on reduction with a cheap reducing agent gives an alcohol. Gives an alcohol. So write down two steps. Carboxylic acid is first reacted with alcohol in the presence of concentrated sulfuric acid. This reaction is esterification. I hope you know, might have studied in 10th standard as well. Esterification gives ester and water. For this, chemical use is very cheap. Sulfuric acid is a very, very cheap chemical. Second step. This ester form has to be reduced. And for the reduction of ester, we can use sodium in the presence of ethanol. Sodium as well as ethanol again are very, very cheap chemicals. We can also use hydrogen in the presence of platinum as the catalyst. Hydrogen is cheap, platinum is expensive, but platinum is being used as a catalyst. And you know, catalysts are regenerated. Catalysts are effectively not consumed. They are regenerated during the reaction. So this will reduce the cost. Will give primary alcohol. This alcohol will be regenerated, right? This alcohol used for the preparation of ester, this will be regenerated. Next method. By the reduction of carbonyl compounds. Carbonyl compounds means aldehydes and ketones. That on reduction of an aldehyde gives a primary alcohol, while ketones are reduced to a secondary alcohol. Reduced to a secondary alcohol. There are two equations. For reduction, we can use lithium aluminum hydride. We can use sodium borohydride, NaBH4. Or we can use hydrogen in the presence of catalyst. Same reducing agent for ketones as well. See what will happen. In both reactions, reaction will take place at C double bond O group. In both cases, double bond will change into single bond. One hydrogen will be added to carbon as well as oxygen. See, double bond changes into single bond. Hydrogen atom added to oxygen as well as carbon. What is this? This is nothing but RCH2OH, that is primary alcohol. Whereas a ketone gives a secondary alcohol. Now, for today, last method of preparation. Before I start this method, let me tell you, this is a very, 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 very important method. There are many conversions which will not be able to solve without this reaction. This will be a lengthy method. You'll have to understand it. I'll give many examples. I'll explain thoroughly. Write down. Method is by the reaction of carbonyl compounds with Grignard reagents. Aldehydes and ketones react with Grignard reagents to form an addition product which on hydrolysis gives an alcohol. Write one more sentence, then I'll start giving you equations. Except methanol, all primary, secondary, and tertiary alcohols can be prepared by this method. Write down equations. RCOR dash may be aldehyde or ketone. If one of the two R's, minimum one of the two R's is hydrogen, it is aldehyde. If none of the two R's is hydrogen, these are alkyl chains, then it will be a ketone. Grignard reagent, R double dash NGX. In this R of Grignard reagent, minimum one carbon has to be present. Therefore, R double dash cannot be hydrogen. R double dash cannot be hydrogen. Now think, I told you about polarity of Grignard reagent, and think of polarity of carbon-oxygen bond. You know, this bond is polar, delta negative, delta positive. Pi bond will break and this will change into a single bond. Negative oxygen will form a bond with positive magnesium. So MgX comes to oxygen. Negative R of Grignard reagent forms a bond with positive carbon of carbonyl compound. Two reactants have combined and given one product. So this is the addition reaction. This is called addition product. This on hydrolysis reaction with water will give an alcohol. Bond between oxygen and magnesium will break. Oxygen due to polarity will be partial negative. Partial negative oxygen will get H plus of water, and positive magnesium will get negative OH minus from water. So products will be OH this product is alcohol, and this byproduct is hydroxy magnesium halide. Hydroxy magnesium halide and alcohol. Say, generally, we do not write the intermediate. I'm saying generally, but you should know at times you may be asked to write. If we do not write the intermediate, what we can do is we write these two reactants. Above the arrow, we write water oblique H plus ions, that is hydrolysis, and write the final product. Right? Two reactants, above the arrow hydrolysis, and write the final product. Now, if you have to write the final product in one step, what you have to do, listen carefully, then I'll give you an example. These two reactants give final product. Think of 3 steps. Step 1, break this double bond, change into single bond. Step number 2, attach hydrogen atom to oxygen. Step number 3, attach this alkyl chain of Grignard reagent to this carbon atom of carbonyl group. Right? That's what you have to do. Pattern. For example, CH3CHO, ethanol, this is isopropyl magnesium halide. Above the arrow, I'm writing hydrolysis. How do I write products? First of all, I should know the structure of CH3CHO. I'm writing here. This is CH3CHO. I'll write here, convert double bond into single bond. This is step 1. Step 2, attach hydrogen to oxygen atom. Done. Step 3, attach alkyl chain of Grignard reagent, it means this chain to this carbon atom. But remember, bond will be formed through this carbon, which is bonded to magnesium. So this carbon atom of Grignard will form a bond here. This is the final alcohol obtained. Why did I say we can prepare any alcohol except methanol? Because this aldehyde or ketone will contain minimum one carbon, that is this one. This Grignard reagent will also contain minimum one carbon atom, and all the carbon atoms of these two reactants are present in the final product. So if both reactants have a minimum 1 plus 1 carbon, it means final product will have minimum 2 carbon atoms. That is, ethanol is the smallest alcohol which can be prepared by this method. Right? Now, I'll draw a table that will be very, very helpful. I hope you're able to see. On the left, carbonyl compound. Left column, carbonyl compound. Right column, alcohol obtained. A part. If R is equal to R dash is equal to hydrogen. I'll read it for you. If R is equal to R dash is equal to hydrogen, it means if both of them are hydrogen atoms, it means this carbonyl compound is HCHO. HCHO means methanol. Then what is the product form? Let us substitute here. This is hydrogen, this is hydrogen. So product will be RCH2OH. I can substitute here RCH2OH. So product will be R-CH2OH. Primary alcohol. B part. Second case is when one of these two R's is hydrogen. One of these two is hydrogen, the other is not hydrogen. So I'm writing if R is not hydrogen, R dash is hydrogen. Then this is aldehyde other than formaldehyde. Aldehyde other than formaldehyde. In that case, product will be R, C, this will be H, double dash, OH. It means product formed will be a secondary alcohol. Last case. Last is when none of these two is hydrogen. C, if R is not hydrogen, R dash is not hydrogen, then this is a ketone. And if this is a ketone, product is a tertiary alcohol. Now look at this table quickly. It means if I want to prepare a primary alcohol, I will react a Grignard reagent with formaldehyde, HCHO. If I want to prepare a secondary alcohol, I'll have to react a Grignard reagent with an aldehyde which should not be formaldehyde, some other aldehyde. If I want to prepare a tertiary alcohol, then Grignard reagent will have to be reacted with a ketone. Now, just before this table, I gave you one example in which on the left hand side reactant was CH3CHO. You can see, you can check your notes. Just before the table, reactant was CH3CHO. It means an aldehyde other than formaldehyde. And check what is the product. Product is a secondary alcohol. Can you check? Can you see that? It's a secondary alcohol. Right?
Yes, sir.
So this is according to this table. If it is aldehyde other than formaldehyde, secondary alcohol will be obtained. Now, I'll give you examples for reverse calculation. Means if you are given product that is alcohol, what are the reactants for its formation? That will be something very, very important. Before I give you examples, look at this equation. I did not rub it purposely. This carbon atom which carries OH group, this originally comes from C double bond O. Apart from OH group, this carbon is bonded to three substituents. These three may be alkyl chains or maybe hydrogen atoms, three substituents. But out of these three, if there is hydrogen, that hydrogen will not come from Grignard reagent. Hydrogen in any case will come from the carbonyl compound, and remaining will come from either of the two. Now let us try. If I want to prepare one propanol by this method, then what are these two reactants? First of all, complete the valency of carbon to which OH group is attached. Second step, I told you carbon to which OH group is bonded, that comes from C double bond O. So this comes from C double bond O. Apart from OH, this carbon is bonded to two hydrogen atoms and one ethyl group. I told you hydrogen will not come from Grignard reagent. It means both hydrogen atoms come from carbonyl compound. Now third is ethyl. Ethyl comes from Grignard reagent. These are the reactants. Moreover, let us check on the basis of the table. This product is a primary alcohol. And for the preparation of primary alcohol, what does your table say? Grignard reagent has to be reacted with HCHO, and you can see this reactant is HCHO, that is methanol. More examples. Let us say I want to prepare 2-propanol. Again, first of all, we complete valency of the carbon to which OH is attached. Sorry, hydrogen. This comes from C double bond O. Hydrogen bonded to this carbon comes from aldehyde or the ketone part, that is carbonyl compound. Now we are left with two methyl groups. One methyl comes from here and the other comes from here. You can see product is a secondary alcohol, and to prepare a secondary alcohol, I've used an aldehyde other than formaldehyde. We'll take 2 or 3 more examples so that it becomes a little complicated, although it is not. Again, we want to prepare a secondary alcohol, 2-butanol. Valency satisfied. This comes from C double bond O, already written on the left hand side, and that too 2 times. H comes from carbonyl compound. H from carbonyl. Now we are left with 2 alkyl chains, and 2 alkyl chains are different this time. One is ethyl, the other is methyl. If ethyl comes from here, then methyl will come from here, or vice versa. It means CH3 and ethyl. So these are 2 possible answers. Both answers are correct. Moreover, according to the table, to prepare secondary alcohol, in both the answers we have used an aldehyde other than formaldehyde. One thing more, how many answers are possible? We come to that. How many answers are possible will depend on how many different type of alkyl chains are attached to this carbon atom to which OH is bonded. If, look here, if both the alkyl chains are same, then only one answer is possible. If 2 different alkyl chains are attached, then 2 answers are possible. You can see. If 3 different alkyl chains are present, then 3 different answers will be possible. I'm taking up the last example now. Quickly tell me, if I want to prepare this tertiary alcohol, how many answers are possible?
2.
Hmm?
2.
2 answers are possible because these 2 alkyl chains are of the same type, that is methyl and methyl. This one is different. Different type of alkyl chain. Type are 3, type are 2. Therefore, 2 answers are possible. I'll make changes. Please do not copy. Wait for some time. Now, how many answers are possible?
2.
2. Now, how many answers are possible?
3.
Eh?
Sir, 2.
This time,
Sir, 3.
3 different answers will be possible. Now, you copy down this one. I'll give you 3 possible answers. We are taking up this example. See, it is very easy, very, very easy. What are alkyl chains? Methyl, ethyl, and propyl. See, how should you answer? If methyl comes from here, remaining 2 will come from here. If ethyl comes from here, remaining 2 will come from here. If isopropyl comes from here, remaining 2 will come from here. These are 3 possible answers. So ethyl from here, it means methyl from here, ethyl and isopropyl from carbonyl. Ethyl comes from here, then isopropyl and methyl from carbonyl. If isopropyl comes from here, then ethyl and methyl will come from here. These are three possible answers. Product is tertiary alcohol. And for tertiary alcohol, you can see in all the three answers, carbonyl compound used is a ketone that you can cross check with the example and table. Right? So that's all for today. It has taken a little extra time. That's all.